4 days, 15 hours, 29 minutes. That's how long it took America to build a cargo ship capable of carrying 10,000 tons across Atlantic Ocean during World War II. Ship that would have taken a year to construct in peacetime. Ship that required hundreds of skilled workers using traditional methods. America built it in less than 5 days using assembly line techniques borrowed from automobile factories. German U-boat commander, captured in Atlantic after his submarine was sunk, couldn't believe what he was seeing when American guards showed him footage of Liberty ship construction. "Impossible," he said. "You cannot build ship that fast. This is propaganda." Guards showed him shipyard, showed him assembly line, showed him prefabricated sections being welded together, showed him ship sliding into water just days after keel was laid. German commander watched in silence, then said quietly, "We never had chance, did we?" He was right. Germany built approximately 1,000 U-boats during entire 6 years of war, took months to construct each submarine, required skilled workers, specialized facilities, increasingly scarce materials. German submarine construction peaked at 30 boats per month in 1943, then declined as Allied bombing destroyed shipyards and materials became unavailable. 1,000 U-boats total, built with enormous effort, represented Germany's maximum industrial capacity for submarine warfare. America built 2,700 Liberty ships in 4 years. Not submarines, cargo ships, much larger, carrying capacity measured in thousands of tons rather than dozens. America built these ships faster than Germany could sink them. U-boats sank 3,000 Allied merchant ships during war. Seems like massive victory for Germany. Except America and Britain built more than 5,000 replacement ships while fighting war. Germany couldn't sink ships faster than Allies built them. This wasn't battle of tactics or courage. This was battle of industrial capacity, and Germany lost before first torpedo was fired. Let's talk about how America revolutionized shipbuilding, how assembly line techniques created maritime production miracle, and why German prisoners of war who saw American shipyards realized their nation never had chance of winning war at sea. This is story of Liberty ships, the mass-produced cargo vessels that won Battle of the Atlantic through overwhelming industrial superiority. Subscribe for more stories about American production capacity that defeated Axis powers. Let's begin. The story starts with crisis. Summer 1940, France had fallen to Germany. Britain stood alone. German U-boats prowled Atlantic, sinking British merchant ships faster than Britain could replace them. Britain needed food, fuel, weapons, ammunition, raw materials, everything required to continue fighting, and all of it had to cross Atlantic Ocean from America. Problem was, German submarines were destroying British merchant fleets systematically. Britain lost 4 million tons of shipping in 1940 alone. Doesn't sound like much until you understand that Britain's entire merchant fleet was only 21 million tons total. Losing 4 million tons in 1 year meant Britain was losing nearly 20% of maritime capacity annually. At that rate, Britain would run out of ships within few years, even if no other losses occurred. And losses were accelerating. U-boats were getting better, tactics improving, wolf pack formations devastating convoys. American government understood that Britain's survival depended on keeping Atlantic supply lines open. President Roosevelt wanted to help, but America wasn't at war yet, and selling weapons to Britain violated neutrality acts technically. Roosevelt found a workaround. Lend-Lease program, announced March 1941, allowed America to lend war materials to Britain with understanding they'd be returned or paid for after war ended. Everyone knew this was fiction. Ships sunk by U-boats wouldn't be returned, but it provided legal framework for American aid. Lend-Lease solved political problem but created logistical nightmare. America could produce weapons, food, and materials Britain needed. Problem was getting these supplies across Atlantic. British ships were being sunk. American merchant fleet wasn't large enough to handle the additional burden. Solution was obvious. Build more ships. Many more ships. Enough ships that even with U-boats sinking them, sufficient vessels survived to maintain supply flow. Traditional shipbuilding couldn't meet this requirement. Peacetime construction of a cargo ship took 8 months to a year, used skilled labor building each ship individually as a custom project. Riveting hull plates together required teams of expert riveters. Fitting engines, plumbing, electrical systems required specialized workers. Each ship was essentially handmade, which made it slow and expensive. America needed ships faster and cheaper. Needed ships that could be built by unskilled workers using standardized processes. Needed ships that could be mass-produced like automobiles. This seemed impossible. Ships weren't cars, couldn't just stamp out hull sections and bolt them together. Or could you? Henry J. Kaiser thought you could. Kaiser was an industrialist who made fortune building dams, highways, bridges during 1930s. Had no shipbuilding experience whatsoever. What he had was expertise in mass production, construction management, assembly line organization. When government asked for bids on emergency shipbuilding program, Kaiser submitted a proposal that shocked traditional shipbuilders. He promised to build cargo ships in months rather than years, using prefabrication and welding rather than traditional riveting. Traditional shipbuilders laughed, said Kaiser didn't understand ships, said welding wouldn't work for hull construction, welds would crack under stress of ocean waves, said prefabrication was impossible. Each ship had to be built individually to account for variations in materials and construction, said Kaiser's timeline was fantasy. Kaiser ignored them and got contract anyway because government was desperate and willing to try anything. Kaiser proved everyone wrong. He revolutionized shipbuilding by applying automobile assembly line principles to maritime construction. Instead of building ships from the keel up, one section at a time, Kaiser's shipyards built entire sections simultaneously at different locations, then assembled them like giant jigsaw puzzle. Here's how it worked. Ship was designed as a series of prefabricated modules. Hull sections, deck sections, superstructure sections, all built separately at fabrication shops away from shipyard. Workers who'd never seen ship before could build these sections following blueprints, just like workers in automobile factories built car components without seeing the finished vehicle. Sections were welded together at fabrication shops, complete with plumbing, electrical wiring, ventilation systems already installed. This meant skilled trades could work on sections at comfortable height in sheltered workshop rather than crawling through cramped ship spaces or working suspended over water. Productivity increased dramatically. Worker welding pipe at waist height in warm building accomplished more in hour than worker doing same job cramped in ship's hold in freezing weather. Once sections were complete, they were transported to shipyard and assembled. Giant cranes lifted sections weighing dozens of tons, positioned them precisely. Welding crews joined them together. What traditionally took months of work building ship piece by piece now took weeks assembling prefabricated sections. Keel laid, sections assembled, ship completed, launched into water, all in time frame that would have seemed impossible using traditional methods. Welding was crucial innovation. Traditional ships were riveted, metal plates held together by thousands of rivets hammered in place by teams of skilled riveters. Riveting was slow, labor-intensive, and required enormous skill. Welding was faster, required less skill after basic training, and created stronger joints. But welding had never been used for entire ship hulls before. Engineers worried welds would crack under stress. Kaiser's engineers solved this problem through testing and design modifications. They developed welding procedures specifically for shipbuilding, trained thousands of welders in these procedures, modified ship designs to reduce stress on welded joints, Result was welded ships that proved just as strong as riveted ships, built in a fraction of time. Labor was another revolution. Traditional shipbuilding required years of apprenticeship. Couldn't just hire someone off street and expect them to build ship. Kaiser threw out this assumption. He recruited workers with no shipbuilding experience. Farmers, housewives, store clerks, anyone willing to learn. Put them through brief training programs teaching specific tasks, then assigned them to assembly line positions doing same task repeatedly. Worker didn't need to understand entire ship construction, needed to understand one task: welding this type of joint, installing this type of pipe, bolting this component to that structure. Specialization meant minimal training required. Someone who'd never seen a ship before could be a productive worker within weeks rather than years. Women were a large part of this workforce revolution. Rosie the Riveter became an iconic image of women war workers, though by the time Liberty Ship program was full swing, riveters were being replaced by welders. Doesn't matter. Women welders were just as important. Women comprised a significant percentage of shipyard workers, doing everything from welding to crane operation to quality inspection. German POWs working at American ports saw these women workers and couldn't process what they were witnessing. German ideology held that women belonged at home raising children, not working in heavy industry. Seeing women building ships challenged German assumptions about American weakness. If America could mobilize women into industrial workforce this effectively, American productive capacity was far larger than Germany estimated. Results were staggering. The first Liberty ship, SS Patrick Henry, launched September 1941, took 245 days from keel laying to launch. Still faster than traditional construction, but not revolutionary. As workers gained experience and processes improved, construction time plummeted. Average time dropped to 42 days by 1943. Some ships were built even faster. The record was set November 1942 by SS Robert E. Peary, built at Richmond's Shipyard No. 2 in California, Kaiser's facility. Keel laid November 8th, ship launched November 12th. 4 days, 15 hours, 29 minutes from keel to launch. This wasn't just fast by wartime standards, this was impossible by any previous standard. Ship that would have taken a year in peacetime, built in less than a week. Launching ceremony for Robert E. Peary was propaganda event. Newsreel cameras filmed workers assembling ship, filmed sections being lifted into place, filmed welders joining hull plates, filmed ships sliding into water just days after construction began. Films were shown in theaters across America, boosting morale, recruiting workers. Films were also shown to Allied personnel and eventually captured by Axis forces. German naval intelligence analyzed these films, trying to determine if they were faked. Seemed impossible that ship could be built that quickly. Intelligence officers studied footage frame by frame, looking for evidence of trick photography, staged scenes, propaganda deception. They found none. Americans really were building ships in days. This realization was devastating for German naval strategy. Entire U-boat campaign was based on the assumption that submarines could sink Allied ships faster than they could be replaced. If ship took a year to build and a U-boat could sink it in minutes, mathematics favored Germany. But if America could build a ship in a week, mathematics reversed dramatically. U-boat took months to build, ship took days. Even if U-boats sank 10 ships before being destroyed, America could build 10 replacement ships faster than Germany could build replacement U-boat. Admiral Karl Donitz, commander of German U-boat fleet, understood this math. He calculated Germany needed to sink 700,000 tons of Allied shipping per month to win Battle of the Atlantic, more ships sunk than Allies could construct. U-boats achieved this rate briefly in early 1942, sinking 834,000 tons in November. Looked like Germany might win tonnage war. Then American shipbuilding hit full stride. 1943, American shipyards built 19.2 million tons of shipping, nearly 20 million tons in 1 year. That's 1.6 million tons per month. Even if U-boats sank 700,000 tons monthly, which they couldn't sustain, America alone was building more than double that amount. Add British shipbuilding, and Allied construction exceeded U-boat sinking capacity by an enormous margin. WW2 realized U-boats had lost tonnage war, but continued campaign anyway because giving up meant giving up Germany's only way to strike at Allied supply lines. U-boats kept sailing, kept attacking, kept dying in increasing numbers as Allied anti-submarine warfare improved. By war's end, Germany had lost 783 U-boats out of 1,155 constructed, 68% loss rate. Approximately 30,000 U-boat crewmen died out of 40,000 who served, 75% casualty rate. Most dangerous service in German military, continued long after it was obviously futile because admitting futility meant admitting Germany couldn't win war. Liberty ships themselves were a fascinating example of good enough engineering. They weren't elegant, they weren't fast, 11 knots maximum speed, slower than many warships. They weren't comfortable. Crews lived in cramped conditions, worked in ships that rolled heavily in rough seas. They weren't pretty, utilitarian design with no aesthetic considerations. But they worked. 10,000 tons cargo capacity, could carry tanks, trucks, ammunition, food, fuel, aircraft, anything needed for war effort. Could cross Atlantic in convoy, unload in British ports, turn around and do it again. Could be built quickly and cheaply enough that losing them to U-boats, while tragic for crews, wasn't strategic disaster. Could be operated by relatively inexperienced crews because systems were simple and standardized. Design was based on British ships from World War I, modified and simplified for mass production. Single-screw propulsion, triple expansion steam engine, old technology but reliable and easy to maintain. Oil-fired boilers, 5 cargo holds, 2 masts with cargo booms for loading and unloading, gun mounts for defensive armament, typically 1 gun aft, machine guns on the bridge. Ships were named after famous Americans, mostly deceased: Patrick Henry, Robert E. Peary, John Adams, Thomas Jefferson, Benjamin Franklin. Later ships named after living people, particularly war heroes and important civilian contributors to war effort. Naming ceremonies gave ships identity, made them more than just hull numbers. Crews were a mix of experienced merchant mariners and newly trained sailors. Merchant Marine was technically civilian organization, but merchant mariners during war faced combat dangers similar to military personnel. U-boats didn't distinguish between military and civilian vessels. A merchant ship carrying war supplies was a legitimate target. Merchant mariners died in thousands when ships were torpedoed. Life aboard a Liberty ship wasn't pleasant. Crew quarters were cramped, hot in tropics, cold in northern waters. Work was physically demanding. Loading and unloading cargo required hard manual labor. Food was institutional. Ships rolled heavily in rough weather, causing seasickness. Engine room was loud and hot. Deck work in winter Atlantic meant working in freezing spray and high winds. Danger was constant. A U-boat could strike any time. Torpedo might hit without warning. Ship could sink in minutes if cargo was munitions. If a ship survived torpedo hit, and many did, Liberty ships were tough. Crew had to decide whether to abandon ship or try to save it. Many crews stayed aboard damaged ships, fought fires, made repairs, brought crippled vessels into port. This courage saved numerous ships and cargoes. German U-boat commanders developed grudging respect for Liberty ships. Early in war, U-boats preferred to surface and sink merchant ships with deck guns to conserve torpedoes. Liberty ships' defensive armament made this dangerous. A ship might have inexperienced gun crew, but they'd shoot back, and a lucky hit could damage U-boat. Safer to use torpedo from underwater, but torpedoes were expensive and limited. More importantly, U-boat commanders realized sinking a Liberty ship was temporary victory. The same ship they torpedoed today was replaced by an identical ship within weeks. It was like fighting a hydra. Cut off one head,
II grew back. German naval records show increasing frustration as war progressed. Commanders reported sinking ships, watching for signs they'd hurt Allied capacity, instead seeing more ships than ever before in every convoy.
Production numbers tell the story clearly. 1941, 18 Liberty ships built, production just starting. 1942, 597 ships built, production ramping up. 1943, 1,334 ships built, peak production year. 1944, 698 ships built, still massive but declining as victory approached. 1945, 52 ships built before war ended. Total, 2,710 Liberty ships in 4 years. At peak production, American shipyards launched 3 Liberty ships every day. Every single day, 3 new ships hit water. Germany couldn't match this. Japan couldn't match this. Britain couldn't match this. Only American industrial capacity could sustain this production rate while simultaneously building warships, aircraft, tanks, weapons, ammunition, vehicles, everything needed for global war. 18 shipyards across America built Liberty ships. West Coast yards, Oregon, California, were crucial because they faced Pacific. East Coast yards, Pennsylvania, Maryland, Maine, served Atlantic. Gulf Coast yards supplemented both theaters. Every yard used same standardized design, same prefabrication methods, same assembly techniques. Ship built in Portland was identical to ship built in Houston. Standardization meant crews could transfer between ships easily, meant replacement parts fit any ship, meant repair facilities could service entire fleet. Cost per ship dropped as production increased. Early ships cost roughly $2 million each. By peak production, costs dropped to under $1.5 million per ship. Economies of scale from mass production, experience curve as workers became more efficient, better organization of supply chains, improved tooling and equipment. American industry doing what it did best, mass-producing complex product at declining unit costs. Compare this to Germany's situation. U-boat cost approximately 1 million Reichsmarks in 1940, roughly $400,000 at exchange rates of time, though direct comparison difficult because of currency controls. Seems cheaper than Liberty ship until you consider what you got. U-boat carried a crew of 50, operated for weeks on patrol, could sink multiple ships if lucky, but risked total loss each patrol. Liberty ship carried a crew of 40 plus armed guards, transported 10,000 tons cargo per voyage, made dozens of voyages during war.
More importantly, U-boat was offensive weapon, requiring skilled crew, extensive training, constant maintenance, increasingly scarce fuel and supplies. As war progressed, Germany struggled to maintain U-boat operations. Fuel shortages limited patrols, spare parts became scarce, experienced crews died faster than replacements could be trained. Allied anti-submarine warfare improved dramatically. Aircraft, radar, sonar, code breaking all made U-boat operations increasingly deadly. Liberty ship was defensive asset, requiring minimal crew training, simple maintenance, plenty of fuel from American oil fields. As war progressed, America's position strengthened. More shipyards meant more ships. More experience meant better efficiency. More industrial capacity meant unlimited materials. Allied control of seas improved, making voyages safer. Statistics illustrate this reversal. 1942 was worst year for Allied shipping losses. 1,664 ships sunk by U-boats, total 7.8 million tons. Seems catastrophic, except American shipyards that year built 746 ships totaling approximately 8 million tons. America alone replaced losses. Add British and Canadian construction, and Allied new construction exceeded losses even during worst year. 1943, losses declined to 463 ships, 2.6 million tons, while Allied construction exceeded 14 million tons. 1944, 132 ships lost, less than 1 million tons, while construction continued at high rates. 1945, the Atlantic was essentially Allied lake. U-boats still operated, but faced overwhelming opposition. German POWs captured during Battle of the Atlantic sometimes ended up working at American ports. The Geneva Convention allowed POW labor for non-combat purposes. Loading and unloading cargo ships qualified. German POWs worked on the docks alongside American stevedores, watched endless parade of Liberty ships arrive, unload, depart, return.
One POW, submarine sailor whose U-boat was sunk in 1944, later described experience in interview. "We believed U-boats were winning tonnage war. Command told us we were sinking more ships than enemy could build. We believed this because we saw ships burning, watched them sink. What we didn't see was American shipyards. When I worked at American port as prisoner, I saw truth. Ships everywhere. More ships than I imagined existed. Ships arriving every day. Same ships we sank being replaced faster than we could sink them. I understood then why we lost." This psychological impact was part of America's strategic victory, not just building ships, but demonstrating capacity that broke enemy will. German submariners were brave, skilled, dedicated. They kept fighting despite horrible casualties. But watching their efforts rendered meaningless by overwhelming production broke morale in ways combat couldn't. British crews sailing Liberty ships had mixed feelings. Ships kept Britain alive. Food, fuel, weapons, everything Britain needed crossed Atlantic on these vessels. British gratitude was genuine, but Liberty ships reminded Britain of dependence on American production. Britain's once dominant maritime industry couldn't match American output. This dependence would shape post-war world where American economic power was paramount. Soviet Union received hundreds of Liberty ships through Lend-Lease. Ships sailed Arctic convoys to Murmansk and Archangel, bringing tanks, aircraft, ammunition, food. The Arctic route was deadly. German U-boats and aircraft based in Norway attacked relentlessly. Winter weather was brutal. Many ships and crews were lost, but ships kept sailing because Soviet Union needed supplies to continue fighting on the Eastern Front. Soviet sailors who crewed Lend-Lease Liberty ships were amazed by American construction quality. Not because ships were luxurious, they weren't, but because everything worked. Soviet industry struggled to produce reliable equipment. American ships had systems that functioned as designed. Pumps worked, radios worked, engines ran smoothly. This reliability was itself a form of luxury to sailors accustomed to equipment that broke constantly.
Pacific theater required even more ships than Atlantic. Distances were vast. From California to Australia was 7,000 miles. From Hawaii to Philippines was 5,000 miles. Every bullet fired in Pacific, every drop of fuel burned, every meal eaten by American troops had to be shipped across ocean. Liberty ships made this logistics miracle possible. Island hopping campaign required continuous supply flow. Marines would take island, engineers would build airbase, but island had no resources. Everything needed, food, water, fuel, ammunition, construction materials, medical supplies, arrived by ship. Liberty ships anchored offshore, unloaded cargo onto smaller boats, ferried supplies to beach. Without Liberty ships maintaining this flow, island bases would starve. Japanese submarines tried to intercept American supply lines, but never achieved success comparable to German U-boats in Atlantic. Japanese submarine doctrine focused on attacking warships rather than merchant vessels. Strategic mistake. Sinking American carriers was glorious, but didn't stop American advance. Sinking supply ships would have disrupted logistics. But Japanese never fully committed to commerce raiding, and by time they tried, American anti-submarine warfare was too effective. Japanese POWs captured late in war, brought to American ports, experienced the same shock as Germans seeing endless ships. Japan's merchant fleet was destroyed by American submarines. Japan lost 8.9 million tons of shipping during war, roughly 60% of pre-war fleet.
Japan couldn't replace these losses. Japanese shipbuilding capacity was a fraction of American. By 1945, Japan faced starvation because ships to import food didn't exist. Meanwhile, America had surplus ships, built so many Liberty ships that some never sailed during war, completed too late or not needed. After war ended, America had to decide what to do with hundreds of excess ships. Some were sold to other nations, some converted to peacetime cargo service, some scrapped. Having too many ships was a good problem to have, showed industrial capacity exceeded even massive requirements of global war. Liberty ships continued serving for decades after war. The design was simple enough that ships remained economical to operate. Many served merchant fleets through 1950s and 60s. Some lasted into 1970s. The last Liberty ship in active service retired in 1994, more than 50 years after design was created. This longevity proved that good enough engineering focused on reliability and simplicity could outlast more sophisticated designs.
Several Liberty ships are preserved as museum ships today. SS Jeremiah O'Brien in San Francisco remains operational, one of 2 Liberty ships still capable of sailing. SS John W. Brown in Baltimore also operational. These ships serve as floating museums, teaching new generations about industrial achievement that helped win World War II. Looking back from modern perspective, Liberty Ship Program was a remarkable achievement in industrial organization. Standardized design, mass production, assembly line techniques applied to shipbuilding, welding replacing riveting, prefabrication replacing on-site construction, unskilled labor trained for specialized tasks, women integrated into workforce. All these innovations combined to create production miracle. But the deeper achievement was the demonstration of American industrial philosophy. When faced with seemingly impossible challenge, solution wasn't to build better ships, it was to build more ships faster and cheaper. Excellence wasn't goal, sufficient quantity was goal. This pragmatic approach defeated Axis powers' focus on quality over quantity. Germany built excellent U-boats. Type 7 U-boat was a sophisticated weapon, well-designed, effective. But Germany couldn't build them fast enough. Japan built excellent destroyers and cruisers, but Japan couldn't replace losses. Britain built excellent battleships, but Britain couldn't match American production volume. America built adequate ships in overwhelming numbers. Liberty ships weren't fastest, weren't most sophisticated, weren't most comfortable, but they worked. They were cheap, they were quick to build, and there were thousands of them. Quantity became its own quality. This lesson applies beyond shipbuilding. Modern logistics, manufacturing, supply chain management all reflect principles demonstrated by Liberty Ship Program. Standardization enables mass production. Prefabrication improves efficiency. Assembly line organization maximizes output. Training workers for specialized tasks expands labor pool. These principles seem obvious now. They weren't obvious in 1941.
Final numbers tell complete story. 2,710 Liberty ships built. Approximately 200 lost to enemy action, U-boats, aircraft, mines, surface raiders. 7% loss rate. 93% survived war. These surviving ships delivered hundreds of millions of tons of cargo, kept Britain fed and fighting, supplied Soviet Union, enabled island hopping in Pacific, brought armies to France for D-Day, maintained supply lines that strangled Axis powers. German U-boat commander was right when he said, "We never had chance." Not because German sailors weren't brave or skilled, they were. Not because U-boats weren't effective weapons, they were. But because Germany couldn't match American industrial capacity, couldn't build submarines faster than America built replacement ships, couldn't sustain losses America could tolerate, couldn't win war of production against a nation whose factories could build a cargo ship in 4 days. This is how America won Battle of Atlantic, not with better tactics, not with superior courage, but with assembly lines that produced ships faster than enemy could sink them. Victory through overwhelming industrial superiority.
Liberty ships were unglamorous, utilitarian, mass-produced vessels. They also happened to be exactly what was needed to win war. Subscribe to this channel for more stories about American industrial capacity that defeated Axis powers through production rather than perfection. Like if this changed how you think about naval warfare. Comment with what you think was America's most important industrial achievement in World War II. Share with someone who needs to understand that sometimes winning isn't about being best, it's about making good enough equipment that enemy can't keep up. What will you accomplish when you understand that excellence can be enemy of sufficient and that adequate solution produced in overwhelming quantity defeats perfect solution produced in limited numbers? Because doing enough of the essential things proves you cannot be stopped.